We want to go ahead and now look at some examples of using the quadratic equation formula. Recall in the last video, we provided the proof for the quadratic equation formula. Now, we will be utilizing that formula to solve for the values of x, which will be the roots of the equation. So, a key idea to think about before we even begin is what type of roots will we find? In order to determine the type of roots or solutions we might find, we should focus our attention to the terms that are inside the square root. Those terms are classified or are given the name, the discriminant. Now, what does the discriminant tell you? What information does it relay to you? Well, there are one of three possibilities. If your discriminant, which is the term inside your square root, if that term results in a positive value, then what that information tells you is that you have two real solutions. If, on the other hand, you have the discriminant equating to 0, then you will only have one real solution. And if the discriminant is negative, then you will have a complex solution involving a real number and an imaginary component. Let's look at an example to dissect this. In the following example, we have the quadratic equation 2x squared plus 7x minus 9 equating to 0. The first thing to do is to label each of these terms. The value of A will be 2, the value of B will be 7, and the value of C will be negative 9. The first thing we will look to find is the discriminant. We'll call that big D. Now recall that big D is equivalent to B squared minus 4AC. We will now substitute the A, B, and C values with their corresponding numerical value. So we have 7 to the second degree minus 4 times the product of 2 and negative 9. Recall that the square of 7 is the same as saying 7 times 7, which is equivalent to 49. And the product of 2 and negative 9 is negative 18. Negative 4 times negative 18 is equivalent to positive 72. And then when you add the values of 49 and 72 together, you get a value of 121. Now that we know that this is a positive value, this will imply that you will have two real solutions. Okay, let's go ahead and actually show that is the case. The quadratic equation states the following. Negative b, which we will replace with negative and then parentheses 7, plus minus the square root of 7 squared minus 4 times 2 times negative 9, all over the factor of 2 times 2. Recall that we've already shown what the value of the discriminant will be. So all we will do is replace the term that's inside the square root with 121. So we will now have negative 7 plus minus the square root of 121 divided by 4. Notice that we have a plus and a minus sign. That means we'll have two solutions. But before we show what those two solutions are, we have to recall what the square root of 121 is. Now, for those of us unfamiliar, the square root of 121 is 11. In other words, if I take 11 and multiply it to itself, I'll get 121. So therefore, the reverse holds true. The square root of 121 is just 11. So we will have it in the following fashion. We will have negative 7 plus minus 11 all over 4. There are two possible solutions, and we'll show both of them here. X can either equal to negative 7 plus 11 divided by 4, or x can equal to negative 7 minus 11 divided by 4. Now, if we look at the first solution, negative 7 plus 11 is positive 4. And if you divide that by 4, while any number divided by itself results in 1. On the other hand, the second solution value is of the following form. Negative 7 minus 11 will give you negative 18 all over 4. Now, negative 18 divided by 4 will not give you a integer. It's a rational number, so what we'll do first is we'll try to simplify it. So negative 18 cannot be divisible by 4 in the sense that it won't result in a whole number, but meaning without a decimal portion, but we can reduce it by dividing it by the same factor that both 18 and 4 share in common, which is a factor of 2. So if I divide 18 by 2, I'll get negative 9. If I divide 4 by 2, I'll get 2. Now, negative 9 divided by 2 is just simply negative 4.5. So the set for your solution is either negative 4.5 or 1. What does that mean? Well, that means that if I plug in 1 or negative 4.5 into the x value for our original equation, that would make the statement valid.